Yeah. So now this is the paper that I would want us to look at. Question number 1. If I taught you QA, I must have used the same questions here, but this is advanced management accounting. So we are told here, part B of this question number 1, a study was conducted to examine the predictive ability of economists and finance specialists on future performance of their country. Equal random samples of economists and finance specialists were asked to make predictions of the percentage change in the gross domestic product of their countries. A year later, the actual percentage change of the GDP was regressed against the economists' predictions X1 and the finance specialists' predictions X2. So you can see GDP there is dependent on how many variables? 2, X1 and X2. The accountants or the finance predictions, finance person's predictions, and then we have in this case here the economist predictions. Using statistical software, below is part of the output. This question was set sometime back here, actually in April. Yeah, April 2025. Yeah, just as a semester. Yeah, and the students got a 0, 0. This computer printout. You see here, they have given you a computer output. In this computer output, they'll give you parameter estimates, and then they'll give you what we are calling ANOVA. ANOVA stands for analysis of what here? Variances. So now they want us to compute the values of A, B, C, D, and E. So I want us to copy this parameter estimates table. There is an error there, a small error there. Yeah, so we have there variable. So this is the parameter estimates, Parameter estimates. So parameter estimates, we have the variable, of which the first one is supposed to be constant. The first one is supposed to be constant. We have X1, we have X2. Yeah, and then now we have coefficients. We have coefficients. So coefficients, what do we have here, ladies and gentlemen? We have 0.983. We have a B. Then we have 0.587. Yeah, and then we have the standard error. We have the standard error. So standard error, ladies and gentlemen, what do we have over here? Standard error, A, 0.257. That is standard error, 0.257. Then we have 0.22, 0.225. And then we have what we call the student T ratio. The student T ratio. So student T ratio, what do we have here under student T ratio? 0.34. Yeah. 2.42. 2.42. And then lastly, we have here 2.61. So I will give you exactly 2 minutes for you to be able to copy this table down. And of course, if you attended my class, yeah, please assume that you understood nothing. And even the nothing that you understood it wrongly. So you start writing everything from scratch. I'm telling you these things, the more you repeat them, the more they sink in you. The more you repeat them, the more you become proficient in them. So this is what we call parameter estimates. Parameter estimates. Parameter estimates. Parameter estimates. So please, once you finish copying this table of parameter estimates, can you put your thumbs up like this? Are we okay? All right. I want to give you a story. I always teach with the stories. You see, this T ratio comes from, you must have encountered this before, some table. If you remember your QA very well, QA was also a very easy paper. Every other time they gave you an exam, they were giving you some tables at the back. Those tables, if you remember them, we had the normal table. We had the student T table. Students T table. And then we had this one. How do you pronounce this? not chi. Chi-square, isn't it? Yeah, chi-square. So chi-square like that. Now, this student T table was discovered by a student like yourselves. Yeah. So then we need to know how to calculate what we call T ratio. How do we get the T ratio from this? Before we go to the table, if you remember very well, we were calculating T ratio. T ratio. And anytime they want us to calculate the T ratio, we normally take the coefficient itself, the parameter itself, and then you divide it by the standard error, right like that. Yeah. First, we are computing the T ratio, and then we read the T table value. So anytime they want us to get the T ratio, we take the coefficient, we divide this by the standard who? Standard error. Thank you. Now, using this concept, we can easily get, you see, we have this T ratio. So take the coefficient by the standard error. Coefficient, so we do A. So what is the value of A? So the value of A, I'm using this one, the T ratio is 0.34, which will be equal to the coefficient. Coefficient here is 0.983. And then we divide this by its error. Error, which is what here, somebody? A. So your role is to make A the subject of the formula. Your role is to make A. What have I done? I've worked with the T ratio for this row. Yeah, and to get the T ratio, you basically take the coefficient over the error. So we have the coefficient here, which is 0.983 divided by what here, the error, which is A. And then now you make A the subject of the formula. So making A the subject of the formula, if I just rub this to create some space, yeah, so then this one here will be the same as 0.34A equals 0.983, isn't it? Because I've cross multiplied. Therefore, A will be 0.983 divided by 0.34. So there is a ninja who is inboxing me here at whether this is a video or live. This is live. Of course, there are times we play videos, but this is very live. Yeah, if you call me there, I'll be able to respond live, ask any question, ninja. You'll be able to see it's not a video. But I mean, even if it's a video, I mean, we're here to learn. Yeah, we're here to learn. Even videos can teach you. So what is the value of A, ladies and gentlemen, here? 2.8911 from Rosa. From Rosa, 2.8911. Thank you so much. So then, using the same criteria, are you able to give me now the value of B? Using the same criteria, are we able to get the value of B? Let's see. Are we able to get the value of B? Let's see. Ninja, this one here will not be uploaded because already it is uploaded. Jay, we are done this with you in the evening. If you go to a portal, you'll be able to see it there. Because if I try to upload this one, it will be duplication. It will be duplication. But if in the event you don't get it there, please let me know. Let me know. Yeah, thank you so much. Great. And thanks for attending a little bit. Yeah. So in this case here, the T ratio for this one, I can see it is 2.42. It is 2.42, which will be equal to the coefficient is B over the error, which is 0.257, isn't it? And therefore, B will be equal to 2.42 times 0.257, which will end up giving us what figure? 0.621, 0.621. The other thing, once I finish this, I'll be doing this April 2025 question. So please be looking for that past paper so that you don't waste time. When I finish this question, immediately, I'll be looking at the April 2025 question. So Omondi Mesa gives me a figure of 0.6214, 0.6219. So can we talk of 0.622? Yeah, thank you so much. So that is something you have done very well. The other missing figures are in the ANOVA table. So right there, ANOVA table. Right there, ANOVA table. Right there, ANOVA table. Right there, ANOVA table. ANOVA. Kama ile kamba inasema ANOVA. ANOVA is analysis. Yeah, of what here? Variances. Analysis of variances. So for this ANOVA table, I have to give you some story, a little bit of story here. Tell us there that there are two types of variances. 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 So we have number one, what we call explained variance. And then number two, we have what we call unexplained variance. So we have two types of variances. We have explained variance and unexplained variance. Explained variance is also known as regression model variance. Regression model variance. Regression model variance. This one is also known as the error or residual variance. So there are two types of variances. We're supposed to know that whenever you're looking at what we call ANOVA table, we have how many types of variances? Two. The first one is what regression can manage to explain. Regression will be able to explain some variances. And there are variances that regression will never explain. We call them residual or what here somebody error. If you remember some time back, we used to have polling companies. And these companies here would come and then they would, in this case here, do what here? Tell us. For example, Raila Kibaki. They used to tell us in this case here, Raila will win. Yeah. And then unfortunately or whatever, Kibaki does what here we? And all through they have been projecting Mzee, the right honorable Raila Odinga to win, but he loses. Yeah. So in this case here, why do they make that kind of a projection? Yeah, and everybody for sure sees that this guy is going to win, but he always loses. It's because of this error residual. So perhaps in this case, ladies and gentlemen, when it comes to counting of votes, we have the Oseka-Mago, isn't it? You see, that is not something that now regression can explain. Any forecasting model can explain. Because you see, they are looking at normal. When they're doing these interviews through sampling, they're looking at, if everything goes as it is planned, they're not looking at aspects of, for example, people not turning out to vote, theft of votes, etc. So anytime we have a forecasting model, we shall have that variance that this person has missed. Yeah, he never got presidency, but we can explain this one. Yeah, we can explain this one here. And then, of course, we have some other conditions, factors that are beyond your control. We call them residual or error terms. Error terms. All right. Yeah, of course, somebody may get a little bit sad when we're using these politics, but they are good. These people are friends. These politicians are very good friends, never be cheated. Never get angry at Mwalimu is saying you are, no. They are best of friends. They are playing a game on us, but we shall overcome. Now, ladies and gentlemen, when you look at the ANOVA that has been given to us, what ANOVA has been given to us, we copy that ANOVA table first. We copy that ANOVA table first. So you can see the first column there is the source of the variance. The first column there is the source of the variance. And in this case here, we have, it's either regression. Regression, remember, is what we have called what here? Explained, or what they are calling what here? Error. So the error, ladies and gentlemen, is what we have also called what here? Unexplained. And then we have total down here. Total. So you can see we have the DFs. DFs in this case here, this stands for degrees of what here? Freedom. So degrees of freedom, we have in this case here 2, 11, and then we have 13, like that. Those are degrees of freedom. Yeah. And then we have the sum of squares. We have here the sum of squares. So sum of squares, what do we have here for sum of squares? So sum of squares, I can see 2904.8. 2904.8, 2904.8. Then we have 100.1, 100.1, and then we have there a C. We have a C. And then we have what they're calling MSS. MSS stands for mean sum of squares. So the mean sum of squares, I can see D, 9.1. D, 9.1. And then I can now see clearly there the F value. F value, we like calling it F ratio. F ratio, F ratio, or F value. So the F ratio that we have here, it has not been given to us. It is E. It is E there. So ladies and gentlemen, now they want me to come here and give them the missing D, C, and E. That I'll be able to get pretty fast. That I'll be able to get pretty fast. Or the board. Are you able to see the board now, A1Jiko? Are you able to see the board? Yeah, I'll give you 2 minutes, you copy. So we have the type or the source, regression, error. Then we have a column for degrees of freedom. We have sum of squares, mean sum of squares, and then we have F ratio. Once you finish writing, can you kindly mention there Y for yes? Once you finish writing, mention there Y for yes. Mention Y for yes. All right. So they want me to give them the total sum of squares. Even a good student, you can even see what they did here to get this 13. To get 13, they took this plus this. The same. C is the total. I take this plus this. So C is the total. C is the total. So I will take 2904.8 plus 100.1, which will end up giving me what figure? Today the online students are not giving me numbers as fast as they always do. Esther's given me 3,004.3004.9. Thank you very much. Now look at D. You see already where we have D, we have a 9.1. You see that 9.1 can guide me, can show me what these guys have done. After all, mean, I know there is something divided by something, isn't it? When I'm getting X bar, summation of X over N. So like I know this one here, 9.1, it will be the sum of squares divided by degrees of, can somebody try in this case here dividing 100.1 divided by 11? It will be 9.1. It will be 9, isn't it? It's 9.1. So in short, this D is MSS. D is MSS. So D is MSS. And to get it, we normally take sum of squares divided by degrees of freedom. Anytime they want us to get mean sum of squares, you take sum of squares divided by degrees of freedom. So sum of squares are here, which is 2904.8 divided by degrees of freedom, which are how many here, somebody? Divided by degrees of freedom, which are how many? So according to Madam Esther, she's getting 1452. 1452. 1452. Point to who? 0.5, isn't it? Or 0.4? 0.4. Thank you so much. So 0.4 like that. Thank you so much. Thank you so much. So up to there, are we together? Yeah, great. F ratio or F value is a little bit, not too much, but a little bit complicated. So you can't take like a shortcut. But again, in AMA, if I got this mark and that mark, I'm very way ahead. Yeah, don't have to get everything in AMA. It's about the concept in general. So like this F ratio, this is what I will do to be able to get the F ratio. To be able to get the F ratio, we normally take the explained MSS all over unexplained. All over unexplained MSS. So we normally take explained MSS all over unexplained MSS. So explained is this one. Explained means sum of squares. I rubbed mine. So it is this divided by this. I rubbed mine. but I remember it was 1452 something. 14.4. Thank you so much. So this MSS for explained variance divided by unexplained MSS, which is 9.1. 9.1. So the online ninjas, are you able to confirm whether we are together? The online ninjas, are you able to confirm whether we are together? The online ninjas. All right. So thank you so much. They are following. They are following. So what figure do you get, ladies and gentlemen? 159.6. 159.6. Thank you very much. 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 All right. Now, ladies and gentlemen, after you do that, now you're finished part one, where they wanted us to give them. We have now finished part one, where they wanted us to give them compute the values of A, B, C, D, and E. That now we have done it very well. Then now we have Roman 2, where they want us to give them the estimated regression model. Is that something that you guys think can try? Regression model, that one you can try. You can try. Even if you don't get it, so what? So what? The estimated regression model. The estimated regression model. The estimated regression model. Estimated regression model. Now remember that here we have got how many predictor variables? 2 of them. 2 of them. If you remember, my good students, whenever you guys are writing a general regression equation, this is normally how you write it. This is normally how you write it. So you normally say that our y regression is y equals a plus what here, somebody? Bx. But now remember, we have 2 of them. So b1 x1 plus b2 x what here? X2, like that. So remember that this a is the constant parameter or constant coefficient. Yeah. And then now we have b1. This will be the coefficient of x1. Coefficient of x1 or gradient 1. Gradient 1. b2 is the coefficient of x2, which basically is gradient 2. So are you able to remind Mwalimu what these numbers are? Oh, yes, we have all of them. We have all these numbers. We have all of them. Oh, yes. So you can see here under the coefficients, under the parameters. If you go to the parameters, you'll be able to see, ladies and gentlemen, remember we corrected this. This is supposed to be, constant coefficient is 0.983. We corrected that if you remember the table that we did. So the constant coefficient is 0.983. Yeah. And then the coefficient of x1, which is b there, we were able to compute it, if I remember very well. Are you able to give me the value of b? And then for x is 0.583. 0.587 actually. 0.587. But the value of b, you guys have to give it to me. Remember, where am I reading this from? The coefficients. Coefficients. So b value that you got is 0.622. Thank you so much. So please, online students, ensure that you are able to copy whatever we have on the board. So remember, these are the parameters which the examiner will give you in most cases on the first table. Because whenever it gives you a computer output, it'll give you 2 tables, parameter table and then ANOVA table. Parameter table will help me always analyze the information regarding these parameters. And therefore the equation, our y will be equal to a 0.983 plus b1, which is 0.622x1 plus 0.587 x2, like that. So let me know whether you guys are able to follow. Let me know whether you guys are able to follow. And please, if you have a question, remember I'm called Chief Ninja because of how I assist students. Yeah, there is no question that is foolish. No, we shall always take all questions. We learn so many things from our students. We learn so many things from our students. And honestly speaking, even the way I live today, it's courtesy of my students. Most of the jobs that I'm getting today, I've taught for the last 24 years. Now, the students that I taught long time ago, currently they are chief finance managers, chief finance officers, yeah, CEOs like Joshua Igara, the former CEO of KCB. Now he's at Stanbic, was my student. Yeah, and of course, those who know, these guys may not be knowing, I belong to two great professional bodies. Yeah, I'm a structural engineer, civil engineer, and I'm an accountant. So like most of the jobs, I don't think whether there is any job at Aura and the company, that we have ever gotten without, in this case here, help from our students. So students in this case here will send us like RFPs. They'll tell us in this case here, you go ahead and make this proposal. And then I don't know what happens, abracadabra, I'm told come and sign the contract like that. Yeah, some of the buildings that I'm doing today belong, not all of them, but some of them belong to my students. But now remember, when you're looking for a structural engineer, don't come to a structural engineer, tell the structural engineer to do structures for you. If, for example, your house is less than, it has to be something like 30. It has to be a big building. Yeah, big building. But even this one, you can still get a structural engineer, but yeah, we shall overcome. So that we've been able to do very well. Now we can go to, and there are mistakes at times. You'll get students who come to me. They tell me, "Mwalimu, want to do this small house here. Please, can you advise us?" And when you look at this small house, it's a maisonette. But then you realize that this guy is telling you that I would want, in this case here, to have the master bedroom up. Yeah, because they are still young. It's a young couple. They are looking at having a balcony outside there. This great balcony, which dances a little bit. But now there is an African problem there. If the master bedroom goes up, it means your children bedroom will be where? So at night, okay, not what you're imagining. But if, for example, in this case here, thieves were to come to this house, would you rather they hit you first or they hit your children first? You first, isn't it? So then you should be down or go with the children up there. How about the guest room? If you say your kids' bedrooms to go down, it means that you're mixing them with your guest and you don't know which type of guest will be getting in a few. Those are some of the things that I've always seen students. Even just the other day, I visited some site. Ya mwanafunzi ameniambia, mwalimu, kuja uone. Woi, ukiangalia floor. Yeah. So you see, ukijenga nyumba, hii ground floor inafaa inuke sawa sawa. Ndio maji sikuja kuingia kwa nyumba siku moja. Yeye unaangalia hivyo na hurumia, because unajua ukinyesha hii earth inaenda kiinuka. Already yasa yake kochi. Ni vile huwezi mwambie nyumba hii ushaharibu, ekelea floor ingi. Huwezi mkataza. So those are some of the things in this case that you need to know in advance. And then of course, employ, even if you have a contractor, have a person we call clerk of works, the cow. So let's get back to business. Ilikuwa ni by the way. That was just, but by the way. All right. So when you start making money in the future, in the next 3, 4, 5 years, will you be giving me your constructions to manage? Or you're not foreseeing yourselves up there? We shall be up there, isn't it? Yeah, we shall be up there. Trust you me, I know 3, 4 years from today, you'll be the who is who, so long as you are working smart. And I'll be able to tell you what working smart means. I'll tell you later, not now. Explanatory power of the model. So this explanatory power of the model is the coefficient. Yeah, is the coefficient of determination. Explanatory power. Explanatory power is the coefficient of determination. Coefficient of determination, which is our R squared. Coefficient of determination, which is our R squared. You see, in most questions, the examiner will always give you this R squared And then it will ask you to interpret. But now here he has not given us this R squared, it is asked to calculate it. But imagine it's not a tough thing, because I know that this R squared is explained variance proportion. It is explained variance proportion. Therefore, my R squared will be explained variance in terms of sum of squares, not mean, in terms of sum of squares, divided by the total variance in terms of sum of squares times 100. Yeah, we are overcomers. I love this. We are overcomers, yes. Ben, I'll tell you why. I will tell you why I can't do one for 7 million. I'll tell you later. Yeah. So in this case here, explained variance, but I can come and visit your site just for purpose of giving you the ideas and advice. So are you able to see the explained variance? Are you able to see the explained variance, my good students? Oh yeah. The sum of squares and the explained variance. Yes, I can see them here. Sum of squares explained is regression, isn't it? 2904, 2904.8, all over total variance. All over total variance, which you guys were able to get here as C, yeah? In terms of sum of squares. Could you kindly remind Mwalimu what the total variance was? 3,000? Was it like this, 0.1? Yeah, times 100%, which gives us 0.9, eh? Thank you so much for that. So at the end of the day, what figure are we getting here? Somebody has already given this to me. 96.7%. 96.7%. 96.7%. 96.7%. Thank you so much. So don't forget to, interpret it. This means automatically that the changes, or rather, the predictor variables, that is X1 and X2, can account, that is explain 96.7% of changes in Y. This is an excellent prediction model. This is an excellent prediction model. I mean, in any exam you get 96%, you are really good. You're an A student. All right. So up to there, are we together? Are we really together, my online students? Thanks, Bahati. Thank you so much. Yeah, so we go on to the next one. So the next one, they want us to test the statistical significance of each of the predictor variables, X1 and X2, use a significance level of 5%. Comment on the statistical significance of the model at the 5% significance level, given that the F table's value is 3.98. Ladies and gentlemen, first of all, give us a note there that there are two types of significance stroke hypothesis tests. There are two types of regression. Two types of regression. Significance or hypothesis tests. Full colon. Yeah. So in this case here, these tests, ladies and gentlemen, are which one? We have number one. Yeah. Coefficients tests or variable tests. Coefficients or variable tests. coefficients or variable tests. And then number 2, we have what we call whole equation tests. So coefficients test, you use T statistic. Use T statistic to carry out the hypothesis test. Use T statistic to carry out the hypothesis test for coefficients. How about whole equation? Whole equation, we shall use call it F statistic here. F statistic to carry out that hypothesis test. Yeah. And normally this is very easy. Like number one, if you look at the question that this examiner has asked us, ladies and gentlemen, if you look at the question that this examiner has asked us to do here, if you look at the question that this examiner has asked us to do, Roman 4, test the statistical significance of the predictor variables x1 and x2, each one of them. So automatically this one I'm going to use T. Yeah, because it is either coefficient or variables. And then if you look at 5, comment on the statistical significance of the model now. Model is a whole equation now. So in this case, you can even see in the brackets there, they have given you, not brackets, but they have given you there F tables. So first of all, we handle number 4. So then number 4, what are we going to do in number 4? So number 4, what we shall be doing, ladies and gentlemen, for number 4, to be able to test, so mention there, a hypothesis test of variables, hypothesis or significance test. Significance, how significant is this variable? Yeah, test. Yeah, so in this case here, number 1, read the T tables value. You read the T tables value first. T tables value. And for us to be able to read the T tables value, what do we need? Data requirements. What do we need? So data requirements, A, we need, my good students, the level of significance. Level of significance. Level of significance that we call alpha. We need that level of significance that we call alpha. Yeah, we need level of significance that we call alpha. That is our A. And then B, we need degrees of freedom. We need degrees of freedom. Degrees of freedom. Actually, these are the error degrees of freedom. Are you able to see them from your table there? The error degrees of freedom, is there somebody who is able to see them? The error degrees of freedom. Anybody who is able to see them from the table? From my table, the error degrees of freedom that I'm able to see, ladies and gentlemen, yeah, from this table, the error degrees of, there are 11, isn't it? We haven't yet seen, under the ANOVA, they have not yet seen error. You'll be able to see error degrees of freedom, they are what here? 11. But you see, in most cases, they won't give you that. So the degrees of freedom, the error degrees of freedom are 11. But in most cases, you must remember the formula of getting this. To get these degrees of freedom, we normally take n minus k minus 1. N minus k minus 1. N minus k minus 1. Where, of course, n is the sample size. Sample size or number of observations. Or number of observations. Number of observations. K, ladies and gentlemen, K stands for number of predictor variables. Number of predictor variables. Number of predictor variables. Number of predictor variables. Like in this question, how many predictor variables do we have? 2. Because it was y equals a plus b1 x1 plus b2 x2. You see predictor variables are these x1 and x2. So in this question, our K is 2. Our K is 2. Our K is 2. Now, in this question, this examiner was very, very brilliant. He never gave students sample size. So if he doesn't give me the sample size, what will I do in an exam? Cry? Crying can never be part of my equation. I will not cry. So he never gave us that. If you give permission to explain this further, because this is really, really important. But first of all, before I even explain further, let's go ahead and read this so that I can finish this and then I rub. Remember, level of significance, this alpha, they have given me a percentage. They have given me a percentage. They have told me the significance level is how much? 5%, isn't it? 5%. 5%, like that, 5%. Yeah, the other thing you're supposed to know, for our significance test here, for the T, we always use what we call two tails. Two tails table. Two tails table. Yeah, two tails table. Yeah, we shall always use what we call the two tails table. Very, very important. So then I don't know whether you have this T table from your past papers. From your past papers. If you don't have them, I'll be able to share what I have here. The T table. So for the T, it shall always be how many tails? Are there situations where we have 3 tails? No. No. It's either 1 tail or 2 tails. Now, ladies and gentlemen, please listen and listen to me very well. You can see I have a table. Have you gotten a table there? T table. It's called student T table. If you don't have, you can just take this, and then when I finish this class, I'll be able to show you. So you can see here, we have degrees of freedom, and then we have 2 tail tests. I'm after 5%. Yeah, this column of 5%. So you go down to 11 degrees of freedom. So the T table is 2.201. Don't worry about that. I'll be able to show the 3 of you. Don't worry about that. You see, our level of significance is 5%, and we are carrying out 2 tail. So 5%. So we have here 2.201. 2.201. I'll be able to show you guys. Don't worry about that. So the T table is here. Read the T table's value. We are seeing it is 2 point. Don't just write this the way it is. I'll show you how to get it. So remember, we have 5% under 2 tails. Yeah. And then you go down with the degrees of freedom. They're 11. You'll be able to see that 2.201. You'll be able to see that 2.201. And now, ladies and gentlemen, once you get that, but before I even continue, there is some clarification I would want you to know. There is something I wanted to explain here for you to be able to know exactly how that 11 was obtained. Please listen and listen to me very well. Listen and listen to me very well. Listen and listen to me very well. We have 3 types of degrees of freedom. There are 3 types. You can take this down, that there are 3 types of degrees of freedom. There are 3 types of degrees of freedom. There are 3 types of degrees of freedom. So number 1, we have what we call explained degrees of freedom. We have error degrees of freedom. Number 3, we have total degrees of freedom. There are 3 types of degrees of freedom. Okay, great. Yeah. So the 5%, of course, will be, so long as, you know, the examiner it can't be constant. At times, the examiner will tell you it's 5%, Julius, at times 10%. Yeah. But in the event the examiner is silent, we shall always use 5%. Yeah, always. But now, once you take 5%, then degrees of freedom, you just go down like that. All right. So we have got 3 types of degrees of freedom. We have what we call explained degrees of freedom, error degrees of freedom, and then we have the total degrees of freedom. Now, ladies and gentlemen, for us to be able to get these total degrees of freedom formula, To get total degrees of freedom, we normally take n minus 1. To get total degrees of freedom formula, we normally take n minus 1. Like in this question, have they given us the total degrees of freedom? There are 13 total degrees of freedom. If you look at that table very well, the total degrees of freedom, there are 13. If you look at this table very well, that not this one. If you look at this table very well, ladies and gentlemen, my good students, if you look at this table very well, you'll be able to see the total. You'll be able to see the total degrees of freedom. So the total degrees of freedom here, total degrees of freedom, there are 13. I hope you're able to see them. Which will be equal to n minus 1. N minus 1. N we don't know, yeah. But now because we have everything, we can easily get n. Now we can easily get n. Is there someone who is able to see that n will be 14? Because when this minus 1 crosses over, it becomes plus. Yeah. So the online students in this case, they started becoming very, very quiet. Very, very quiet. Because this will cross over, isn't it? So it becomes n equals 13 plus 1. Which gives us what there? 14. Now, please listen and listen to me very well. The explained variance will always be equal to number of predictor variables. Will always be equal to number of predictor variables, which will be equal to k. K. So number of predictor variables, which is equal to k. Are you able to remember the number of predictor variables that we have in this question? Please talk to me. How many predictor variables do we have in this question? So k will be 2. Thank you so much. So this is 2. And that is why, ladies and gentlemen, if you look at this very well, you'll be able to see up here, regression, which is the same as explained. Has how many degrees of freedom? 2. Then let's get this error. The error, degrees of freedom. So the error, given you the formula. To get error degrees of freedom, we are taking n minus k minus 1. And fortunately, we have everything there. N minus k minus 1. So our n happens to be equal to what? I am alone, but I will overcome. It's 14n, isn't it? Minus k, which is 2, minus 1, isn't it? So then this one here will end up giving us what figure? That is how they got their 11. That's how they got their 11. So please listen and listen to me very well. You know, in most cases, they will not give you these degrees of freedom. Whenever it comes to regression, reading of the T critical, we call it T critical or T tables value, we shall always use that n minus k minus 1. Because we want to see whether our predictor variables, do they have errors? So you're using the error degrees of freedom. We're using the error degrees of freedom. So up to there, ladies and gentlemen, somehow are we together? Are we together? Yes. So then let's continue So then what you want to do here, my good students, remember already we have read the T tables value. And we have gotten in this case here T tables value as 2.201. And now this happens to be what we call the hurdle rate. So then you will be able to now go to the coefficient T ratios. Now look for the coefficient T ratios and evaluate them. So the coefficient T ratios, we start with the first T ratio given there. Yeah, for the constant. So the constant T ratio that we have there, my good students, you can see the T ratio that we have. Yeah, the first one is 0. What here? The first one. Is there someone who is able to see 0.34? Yeah, so 0.34, and this 0.34 is insignificant. It's smaller than the significance value. This is smaller, isn't it? So in this case here, you say this is less than 2.20. It's not big enough. It is insignificant. it is insignificant. So you simply tell us that the constant is insignificant, and this may render is insignificant, and this may render the regression equation useless in terms of prediction. This may render the regression equation useless in terms of prediction. In terms of prediction, it may render, yeah, because I mean, it's a very tiny number. It's not significant. Yeah, remember already we have this t table's value is the significance threshold. Any number which is less than this points to an insignificant coefficient. So then what are you telling this audience of viewers? Because this, for those of you who will be doing your MBA thesis, PhD thesis, you'll be able to get this literature a lot. So you're not telling this person who has done research for a whole year data collection and now they have been able to analyze their data using SPSS, you're not telling them that their whole model is useless. No, you are telling them that this is insignificant and therefore they need to consider increasing the sample size. 14 could be too low. So if I'm your supervisor, then I'll be able to tell you, hey, this sample size, no, go and get, in this case here, other people to interview. Yeah, to interview like that. But for your case, it's all about significance, insignificance analysis. So then we take on the second variable, the second coefficient. We have a T ratio there, which is 2.42. So we have this T ratio, which in this case here is for X1, which in this case here, you are telling me it is 2.4 what here? 2.42. So please, could you kindly compare this with our hurdle rate of 2.201? It's more, isn't it? This is greater. This is greater. This is greater. So this is greater than this 2.201. So meaning that X1 is significant. It's big enough. X1 is significant, meaning that X1 is significant. X1 is significant. It's good. It's a good predictor variable. X1 is significant. Then we have the next T ratio. The next T ratio now is for X2. The next T ratio is for X2, which happens to be equal to what here? The next T ratio is for X2. I mean, I would want you later on to do the April. I hope you'll be able to get some time to do the April question. You will see how easy it was. So in this case here, we have the T ratio for the third coefficient, or X2, which is 2 point what here? 2.61, isn't it? Is there somebody who is able to see that this is greater than 2.201? It's greater, yes. And therefore, X2 is equally what here, is equally significant. It is equally significant. It is equally significant. It's equally significant. So, ladies and gentlemen, up to there, apart from the students that happen to be having physical here because we never had a T table, yeah, the online guys have been able to share online a T table. I'll be showing you how we got read the 2.201. But the online ninjas, have you been able to follow? Have you been able to follow this? The online ninjas, are you okay? The online ninjas, are you okay? The online ninjas, thank you so much. So then we go to the very last one, the very last question there. The very last question there, they want us to do something very easy. The very last question there, they want us to do something very easy. They want us to do something there very easy, easy peasy. So the last one here, 5, they want us to comment on the statistical significance of the whole model, the whole equation at the 5% significance level if F table's value is 3.98. So remember, F table has never been given by your examiner. That is why whenever it comes to the F table, your examiner will always give you the table's value, which really makes everything very easy. Makes everything very, very easy. So then, ladies and gentlemen, if they want us to do whole equation, so that's number 5, whole equation. what we are calling whole model hypothesis or significance tests. We are using the F statistic. We are using the F statistic. And the F statistic, number one, read F, tables value. Tables value. Where are you reading it from? You will always be given this. It's a free mark. It's a free mark. This will always be given. 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 So because we are doing for just one, model. Now from there, we go to the F ratio now. F ratio calculated. You can call it calculated F ratio for the model now. So the calculated F ratio for the model, fortunately, I know you remember how you were calculating this. Explain the MSS. I know you remember how you were calculating this, although I don't want us to calculate it again because we calculated it. There's somebody who can be remembering it. It was coming to 159. 159.6. Thank you so much. 159.6. So, ladies and gentlemen, please listen and listen and listen to me very well. Listen and listen and listen to me very well. The figure that we have here is much bigger than 3.98 because this is the significance. The one you read is the significance, telling us that any model whose F is bigger than this, it's just like in Kenya here, we look at the significance age of adulthood to be 18. Anybody who has more than 18 years is an adult. Yeah, is an adult. So 159.6 is more than 3.98. So meaning that the whole model is big enough. The whole model is significant. 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 It's big. It's big. So, ladies and gentlemen, with your permission, I will be able to go straight away now to the April question. April question, perhaps you could take a short break of how many minutes? Of course, I'm sure whenever you take short breaks, the online students in this case here disappear, but so what? Yeah, that's life. But somebody in this case who is thirsty for this knowledge will come back. Yeah, we take a break of 5 minutes. When we come back, we should be able to continue with the April question, April 25. So then we shall be able to come back at exactly 12:20. 12:20. 12:20. So let me stop recording. Yeah, somebody should be able to share with Esther the past papers. Stop now, pause. So this was really a pre-2025 question number 4, boy, was really, really, really an easy paper. Was an easy paper. Even the question itself was really easy. So I read Global Logistics Limited as 2 operating segments, Longonot Division and Nzoia Division. Longonot Division orders most of its consignment of intermediate products from Nzoia using EOQ model. The managers of each division are given considerable autonomy in transfer pricing policies. Longonot Division managers want to use multiple linear regression analysis to evaluate the significance of independent variables on material handling cost of its consignment. The finance director of Global Logistics Limited has availed the following data for Longonot Division for the past 10 months. So we have months, we have material handling, number of orders, number of kilograms. So you can see we have Y, X1, X2, what we call multiple regression, multiple, not single. Then they have given us geniuses, good people. They have given us a computer output. And then I can see summary output for the regression statistics. Very good, very good. I can see the ANOVA table, very good. And I can see the parameter table. So they want me to write down the multiple linear regression there. Y equals A plus B1, X1 plus B2, what here? X2. So they want me to write y equals A plus B1 x1 plus B2 x2. So are you able to see the value of A in the parameters? In the parameters, I can see the intercept 507.3097. Yeah, plus B1. B1, what do we have here for B1? 7.835162. 835162. 835162. X1. Plus, ladies and gentlemen, the third one, which is 0.107181. 0.107181. X2. You have your, how many marks? 2 marks. In an exam, do you think in this case you would have gotten that correctly? In an exam, do you think you would have gotten that correctly, ladies and gentlemen? Great. Thank you so much. That is really easy, easy peasy. Great. Then, ladies and gentlemen, we shall be able to go to number 2. So number 2, they want us to, you can see here, suppose in the month of April 2025, Longonot division expected to have 350 orders. If you remember very well, orders were X1, So basically, X1 is 350, 17,000 kilograms of material, so that is X2. Predict the total material handling cost for April 2025. Very easy. Already I have a predicting model. So Roman 2, we have our Y will be 507.3097 plus 7.83516. Yeah, 2. X1 is 350, right? Plus 0.107181. X2 is 17,000. You have your mark, 1 mark or 2 marks. You disappear. Quite an ugly figure. Yeah, please give it to me if you can. If you can, please give it to me. If you can, please give it to me. So remember the online students, the daytime timetable, we have classes on Thursdays and Fridays, 11 to 1. 11 to 1. I always endeavor to attend all my classes, but at times, daytime, there could be little disruptions, but I will ensure that I will attend over 90%. Over 90%. Yeah, great. So 2 marks, 3 marks really. At times 1 mark for prediction. Is that okay? Boy, nobody's giving me an answer. Nobody's giving me. So according to this ninja, they're getting 5071. No, they're saying no. They're saying that cannot be the correct answer. 2 ninjas, online ninjas, have given me that answer. This must be the correct one. 5071 point. Check. 2 people, most probably who are seated in very, very different counties in Kenya, cannot conspire to give me that big number, and then it is wrong. 0.69, right? Or something, yeah. So that is correct. I hope my great sister there will be able to get that. All right. So for the online students, do we have students online who have already paid the fees to RCM, that you are RCM students? My online students, do we have RCM students, or are you, all of you, strangers to RCM? Ah, great. Paid, great. Then the other students who have not yet paid, I would want to welcome you formally, please. We are charging good amounts for these online classes and the physical classes. If you would want to come and study with us physically here, call this number 0793 555 000 and make your inquiries. Yeah, you can see this is not an easy job. Paid for 4 units. Thank you so much. It's not a very easy job. Would want you to support us fully. Would want you to support us fully. So Esther, if you don't mind, please, if you chat up with this lady, she'll be able to give you all the information, and I will be happy to see you, Esther, in my class. Because I can see you are aggressive, I will be happy to receive you formally in my class. All right. So then, they want us to compute the missing values, W and Z. We start with W. W is sum of squares. I will be able to use the mean sum of squares formula. Eh? Yeah. So in this case here, we know that mean sum of squares, equals sum of squares over degrees of freedom. So we have here mean sum of squares equals sum of squares over degrees of freedom. So in this particular row, where they have given us the W, I can see great things happening there. So, ladies and gentlemen, where they have given us this W, you can see 7W and this one here. So the mean sum of squares is 5739.99. 5739.99 equals sum of squares that is not known, which is being called W. All right, divided by same residual, the degrees of freedom are how many? 7. So then I can easily make W the subject of the formula. I can easily make W the subject of the formula. So then W will be 5739.99 times 7, which approximately gives me what figure? Which approximately will give us what figure? $41.79 $300. Oh, gorgeous. 4179.93, isn't it? 0.93, yeah. 0.93. 0.93. Thank you very much. Now from there, they want us to give them the other unknown variable. So the other unknown variable here is Z. And this one is under T ratio. Then I must be at a position of remembering how T ratio is computed. The moment I remember how T ratio is computed, I'll be able to connect the three. To get the T ratios in German is not really a hard thing, no. It has never been a hard thing, no. To get the T ratio, this is normally what we normally do. So I want to evaluate Z. And to be able to get this Z, remember this is under T ratio. And to get this T ratio, we normally take the coefficient divided by what here, somebody? Standard error, corresponding standard error of the coefficient. So then be keen enough, under this residual, is there somebody who is able to see the T ratio? Remember the missing term is under variable, actually, variable 1, this Z. So you can see the T ratio corresponding for this variable is 33.47. So T ratio is 33.47. 33.47. Yeah, 33.47, 672 equals coefficient that has been given there for X1. The coefficient is 7835. 162 with a decimal here divided by the standard error that has not been now provided, which they have given to us as Z. They've given us this as Z. So go ahead and cross multiply. It will be 33.47672 times Z equals 7.835162. Therefore, Z will be 7.835162 divided by 33.47672. which will end up giving you guys what answer? According to Julius Moravi, 2340, right? 2340, 2340. Bahati has confirmed that. Bahati has confirmed that 2340. The physical students, have you been able to confirm this? Great. Thank you so much. Great. So in an exam, do you think you would have easily gotten this by yourselves? I mean, the better question should be, now should they bring this kind of a question on an exam? Are you at a portion of answering? Yeah. You don't have to get everything, but at least many areas should be very familiar. Many areas should be very familiar. So we continue. So 4, explain the significance of regression statistics output over R squared 0.99. Yeah. So the significance of this, very easy. I will get all the marks. I'll change it first of all to percentage. I will change it to percentage. It is 99. So the percentage, that R squared will be 99.88. 99.88. Are they okay? Yeah. In terms of percent, this is like that. This is like that. 99.8841. So they want me to explain the significance of this statistic. So how do I interpret this, ladies and gentlemen? It means that x1 and x2, remember this is explained, actually if you say it's explained variance proportion, and I say that this is very high, this is very high, and therefore the model is excellent for prediction. This is very high, and therefore the model is excellent for prediction. You'll get all the marks. 99.8841% is really excellent. Yeah. But now in this case here, a technical person like yourselves, you can make a better explanation than that. Because what you need to come and tell us is that x1 and x2 can account or explain, yeah, 99.8841% of the changes in response variable y. So 99% is so high, so we don't need to look for any other predictor variable. We don't need, in this case here. Yeah, that's very good, Julius. Very good. Thanks for attempting it. That's very good. Thank you so much. And then now, with your permission, I'll be able to go to the last question. So the last question here, yeah, based on the T ratio value, just the T ratio value. They don't want you to get the T tables. Based on the T ratio value, explain whether the number of orders, which is X1, or number of kilograms, which is X2, ordered is more significant in predicting the total material handling cost. So, ladies and gentlemen, remember that the higher the T ratio, the better the predictor variable. The higher the T ratio, the better the predictor variable. The higher the T ratio, the better the predictor variable is. The higher the T ratio, the better a predictor variable is. So they tell you to compare the significance of two variables on the basis of the T ratio. You simply tell us the one that has a higher T ratio is the best, is the better one. So like, look at the T ratios provided. Look at the T ratios provided, ladies and gentlemen. Look at the T ratios provided. There are two of them. Are you able to see them? So if you look at the T ratios provided, we have for X1, that 3. For X2, it's 28. So in that case here, you simply tell us there that X1 is more significant than X2. X1 is more significant than X2, simply because it has a higher T ratio. Because they never wanted you to do any significance test. On the basis of the T ratio values between the two, which one is more significant? It is the one that has a higher T ratio. It is the one that has a higher T ratio. Ladies and gentlemen, it has been lovely hosting you today. I'm looking forward in this case here to meeting you next week for the ones in this case here doing in this case here daytime classes next week, Thursday at 11 p.m. Otherwise, bye.